Today's lesson, we're going to continue to study how to simplify and use radical expressions. Today, we're going to look at a different notation for these radicals, which you're going to see rational exponents as our new notation. Now, you'll remember when we were solving radical expressions or equations, we saw those rational exponents of 1/2 power and 1/3 power, and we kind of quickly talked over those. Let's dive in and look at this with a little bit more detail today. So a rational exponent will look something similar to this. So you would have a to the 1/n power. That 1/n power is showing you what the root is. This n becomes the root so that you can write this in radical form. This would be the radical form of the nth root of a. So notice that this is our base or our radicand, and this becomes the nth root of a. Now, if this number is not a 1, if this number is some other value, the number on top becomes our exponent. So when we have to write this in radical form to understand our problems, the denominator still becomes our root, but the numerator becomes our power. Now, whether we change and write the whole root to the power of m, or we just write the a inside to the power of m with the nth root, it does not matter. So the order that you work these problems in, exponent first and then find the root, or find the root first and then complete the exponent, doesn't matter. They have the same precedence and the same level. So if I break this down to you one more time, the rational exponent, the number on top or your numerator becomes your exponent. The number in the denominator is your index or the root. And the number itself, x, is your base. In the radical form, this would also be your radicand. Now, you've seen this chart in previous lessons. We learned how to pull out all of our factors that had perfect squares or perfect cubes in there. We learned how to pull apart the fractions, and we learned how to rationalize the denominator. But this first step, I said, we're going to hold off on this step and we'll see it in a couple lessons. Well, we're going to look at this step today. It says the index n is as small as possible. Well, how could that be? So let's say, for an example, I have a number and it's to the 2/4 power, where it's the 4th root of a number being squared. What I can simply do today is reduce and make that x to the 1/2 power. That fraction up here is going to hold true to all fraction properties, so that I can reduce that to be 1/2. So that would simply change my root to be the square root of x. That made my index n as small as possible. So whenever you can reduce that rational exponent, you need to do that to simplify your expression. Okay, so let's look at just practicing the idea. So it says write a to the 1/6 in radical form. Since 6 is in my denominator, that makes it the root. So this would be the 6th root of a. Technically, it's a to the 1st power, but I don't really need that power of 1. So I can simply write 6th root of just simply a. Then let's work it the other way. How does it work the other way? Write the square root of w in exponential form. So I've explained that if there is no index, we will assume that that index is 2. So if this is the square root of w and there's no power, we will assume that power is 1, and then I can write that as w to the 1/2 power, where 2 is my index and 1 is my power. This is going to help us simplify some operations a little bit easier as we move through our algebra. So this one says evaluate 49 to the -1/2 power. So don't forget that negative a negative power means that we are dividing by that power instead of raising it by multiplication. So simply, this is going to be 1 divided by 49 to the 1/2 power. Or I can make this 1 divided by the square root of 49. That simply can be square rooted as 1/7. So you can see that we can simplify 49 to the negative 1/2 power as just simply 1/7. All right, so let's evaluate 32 to the 2/5 power. So when I do this, I'm going to rewrite it as a radical expression. So I'm going to put my index on the outside, and I will have 32. Now, I like to put my squared on the inside, but as you see at the beginning, it does not matter if you put it on the inside or the outside. All right, now, if possible, I like to take my root first, because if I have to raise 32 to the 2nd power first, it's going to be a very big number to break down. So what I'm going to do is I'm going to do the root first. So I'll take the 5th root of 32 if possible. So I don't know if that has a 5th root, so I'm going to just factor this real quick. And I can see with a quick factorization that 32 is indeed 5 2's. So I have the 5th root of 2 to the 5th power, and then we'll have to square that. So the 5th root of 2 to the 5th power is simply 2, because those will cancel, and 2 squared is 4. So this problem that started as 32 to the 2/5 power simplifies to just 4 once we work through our roots and our powers. All right, so let's look at an example. Now this example is to show us how to do these negative exponents in your calculator. So it's showing us the formula 512 minus 146,230b to the negative 8/5 is used to estimate the total mass that a weightlifter can lift in 2 lifts. And that's the snatch and clean, and that's just a type of lifting where you pull it up very quickly. Suppose a 168 kilogram weightlifter competed in the same weight class. According to the formula, what is the maximum he can lift? So that is going to become his B, the kilograms he can lift. So when I do this, I'm going to go ahead and plug this in, but I'm going to show you how I put this into my calculator. So this is going to be 512 minus 146,230. Now I'm going to use my parentheses, and I'm going to input 168. When I put this in the calculator, I need to use that caret button that shows that I'm going to put in an exponent. Now you can most certainly put this in as negative 8/5. When you do your exponent, you're going to put another set of parentheses here, and you'll do negative 8 divided by 5 and close the parentheses, and make sure you have this whole exponent in parentheses. When you input that into your calculator, just like that, that will show us what the mass is going to be. And that mass should be approximately 471.77 kilograms. So go ahead and try that in your calculator and make sure you get that amount. All right, so let's move on. We're going to do some more simplifying with operations now. So we're going to look at some previous operations that we've learned and apply them to rational exponents. So this is y to the 1/7 power times y to the 4/7 power. So you'll remember that rule when you're multiplying with like bases, you are going to repeat the base and simply add the exponents. So we're going to take 1/7 plus 4/7. So that's going to simplify to y to the 5/7 power. Now I'm going to make sure that I can't simplify that at all. Now if it would ask you to write that in radical form, it doesn't, but we'll just make a practice of it right here. We'd write that as the 7th root of y to the 5th. You can see that 5/7 can't be simplified, so that means our index is as small as possible. So either one of those would be our correct solution. All right, part B says to simplify x to the negative 2/3 power. Again, there's that negative exponent, so I'm going to have to take that negative exponent and put it into my denominator. So this is going to be 1 divided by x to the 2/3 power. Now, I can't reduce 2/3, but I understand that this is really 1 over the cube root of x squared. And remembering our simplification rules, we are not allowed to have a radicand in our denominator. So this problem is going to need rationalized. So since this is the cube root, that means I need 3 x's to come out of here. So I'm going to multiply by the cube root of x on top and on the bottom. So that gives me on top the cube root of x divided by the cube root of x cubed, which is simply just x. Now, I can actually show you a different way. If we leave it to the 2/3 power and understand that this has to be x to the first power at the bottom, so I can rationalize this in rational form if you understand that to make 2/3 be 1, I need another 1/3. So I can multiply the top and the bottom by 1/3. Now notice what's happening here. I'm not changing my math, I'm just changing the notations. So if I do that, I end up with x to the 1/3 power over, repeat the base and add the exponents. And now I can reduce my fraction. 3/3 becomes to the first power, and I have the cube root of x. Do you have to do it this way? No. If you have understood it this way, continue to do so. If this way makes it easier for you, then you can do it that way. So you have alternatives now how to simplify that expression with that negative 2/3 power. All right, so we got a couple more to work through. I see that I have to simplify the 6th root of 16 divided by the cube root of 2. Now, you will remember that quotient rule. Now, 16 can be divided by 2, but because these index numbers or values are not the same, I cannot work under the same radical. So what I'm going to do is I'm going to split 16 apart to see if I can get it down to a like base. Okay, so that gives me on top the 6th root of 2 to the 4th power. Now I cannot break 2 down any further, but what I can do is now write these as rational exponents. So that becomes 2 to the 4/6 power divided by 2 to the 1/3 power. Now up on top, of course I can reduce that 4/6 to 2/3 and 2 to the 1/3 on the bottom. Now you might think that we have to rationalize here, but let's use our division rules where we repeat the base and subtract the exponents. So I'm going to have 2 to the 2/3 minus 1/3 power, or 2 to the 1/3 power. And that simplifies to the cube root of 2. So we were able to simplify that and get our index as small as possible while breaking down what was inside. So you can see how that's going to make our math just a little bit easier to work. All right, so let's look at example B here. It's the 6th root. Now, it's the 6th root of everything inside. It's the 6th root of 4. It's the 6th root of x to the 4th. So I'm going to break that 4 down, and I'm going to see that it is a pair of 2's. So this is going to be the 6th root of 2 squared times x to the 4th. Now, if I pull out my values here, I can rewrite this as 2 to the 2/6 power times x to the 4/6 power. Both of those rational exponents can be reduced. So I'm going to reduce that and make that 2 to the 1/3 power. I'm going to reduce that and make that x to the 2/3 power. Now I can't do any more combining because those are different bases, but I now can rewrite that with an index as small as possible. So this becomes the cube root of 2x squared, which simplified from the 6th root of 4x to the 4th. So we have our index as small as possible. Now for our last example, you can see I have the square root of y plus 1 and the square root of y minus 1. Now I can write that in radical form. Now from the very last lesson that we have completed, you should understand that I can't keep that square root in the denominator. So from here, I'm going to go ahead and conjugate this. Now, if you want to conjugate in rational form, you are welcome to do that. I'm going to go ahead and conjugate in radical form. So my denominator is the square root of y minus 1. So I'm going to make that the square root of y plus 1 on the top and the bottom. So as I work through the foiling of this problem, I have y. My outsides and insides are going to give me 2 square roots of y. My lasts give me 1. In my denominator, the firsts give me y. From conjugating, my outsides and insides cancel out, and my lasts will give me -1. So this is my expression after I finish my conjugation. So don't be afraid of that rational exponent. It just can be written as a radical as well. All right, our last example, we have multiple operations happening here. I have multiplication on the top and I have divided by x to the 1/6 power. So just as I always have done, I use that fraction as a separator. So I'm going to go ahead and simplify the top first. So I have repeat the base and add the exponents. Now when adding, I need to have like denominators. So I'm going to make that real quick be 2/6 plus 3/6, giving myself a common denominator of 6. So that's going to simplify to be x to the 5/6 power. Then I have to divide that by x to the 1/6 power. If I slide back over here, now I need to, because I have to divide, I'm going to repeat my base and subtract my exponents, leaving me with x to the 4/6 power. And again, that's going to simplify. And that will simplify to x to the 2/3 power. Now we can see that it's not going to be d over here, so I'm going to rewrite it as a radical, and my root has to be 3 and my exponent 2. So that's going to leave me with b. All right, I'm going to leave some practice problems for you to do. If you have any questions, please let me know. I hope you all have a great day.